This is Team Menno's project, and our topic is power consumption. Our team consists of Timothy Gray, Nicholas Campos, Jakias Knighton, and Christopher Wills. For our project, we will be looking at power consumption in 3 different zones in 2017 in a city named Tentouan in Morocco. We will be looking at how factors such as weather parameters, the landscape, and type of occupancy may affect this power consumption. We will then find 3 best fitted data models that will be used to predict power consumption in these 3 zones. Our objective is to build an interface that will allow users to add new observations that will automatically update to the data model. For our member roles of our project, we decided that Jakias was going to be the designer as well as help develop the user interface and perform a literary review for the project. Timothy is our leader and is responsible for model building along with data analysis. Nick is our group communicator who's responsible that project development flows smoothly and will assist Tim in data analysis and model building. Finally, Chris is in charge of producing the project's media, covering the documentation of the project, and also responsible for literary review of the reference articles that assist in understanding the project. We'll start off by looking at the database that we will be using for our project. It shows the power consumption from year 2017 in 3 different zones of the city of Tentouan. The data stored in this database is weather-based independent variables of temperature, humidity, and wind speed. Then the power consumption of each of the 3 different zones is recorded in the corresponding columns. Each row of data is measured according to the date time in which it was recorded, and this is measured in 10-minute increments over the course of the year. Our first task is literary research. We will analyze research articles to determine challenges for predicting power consumption. We will use what we learned from those articles to describe the importance of weather effects on power consumption, how they cause increased power consumption, and then we'll summarize the value of a data model in context of how it could be used to predict power consumption. Our next process is exploratory data analysis. We plan to use the pandas function to help us to describe the contents of the given data about the 3 zones and the weather variables. We will use it to find the mean, the median, the standard deviation, as well as other important values of the data frame. We'll also make various observations about the data frame, including things that may have an influence on power consumption. We also plan to make visualizations such as plots and charts that will help describe the data and explain it so the data is easier to be understood. Next, we'll be reformatting the data of the database by addressing any shortcomings such as null values or outlier data points, adjusting the column headers as necessary for purposes of representing the data and performing calculations in a project. We'll also come up with ways to make the data plots more manageable, maybe due to a large size of data or maybe just a lot of calculations so that it's easier to observe and understand. Next up is creating and interpreting pair plots. We're going to be using the Seaborn database in order to create a pair plot for a visual reference and improve the readability of the pair plot so it's easier for the reader to comprehend. We also plan to use these pair plots to recognize correlation patterns and make inferences that reflect the data we observed from the pair plots. For building the data models, we plan to build 3 models for each of the 3 zones. These will be designed with the consideration of which inputs strongly affect power consumption, determined by plotting the independent weather variables against the power consumption in each zone. We will then test the correlation of the scatter plots to determine the strongest factors that play a part on power consumption. After that, we plan to build at least 2 different subset models that sample the original data with enough iterations to create a training set for our chosen model. We will then split that data into a training set data and then test set data, and then use the data to build and train 2 different models that best represent the effects of the weather inputs on power consumption. Possibilities of the data models include root mean, squared error, mean average, percentage error, regression, etc. After those models have been built, we'll assess which model best accurately represents the data by using visualizations of model predictions. How we'll do this is by comparing the model that was trained against the test data, compute error calculations, retest that model against using error calculations, then compute residuals. Then we'll begin building our input data interface. The interface we will build will accept user-defined inputs and use those with our data model calculations in order to predict the power consumption effects from the entered inputs. We will use the console not only to accept the inputs, but also return the estimated power consumption with a specified uncertainty back to the user. The interface will then be able to be used to update the existing database if the user chooses to do so from a prompt via the console. The interface will then use this database to show the predicted power consumption based off the inputs that the user put in. During the second part of our project, we will create a video that will explain how a user can use the interface created, explain the readability and the accuracy of the console's output, and determine how the data can be updated using any interface created. For the final IPYNB, a final copy will be provided in part 2 of the project with all the code and comments explaining the code we use in order to accomplish all our objectives. To conclude, this is our project. It shows the steps that we have to achieve our objective and the subtasks we have for each member to complete. It's not our final draft. We will for sure change things that don't seem to work out for us, but this is the step and the direction we are taking to accomplishing it.